Hello kids, I'm back again with Standard 8 Physics, chapter number 2, Physical Quantities and Measurement. In this video, we will continue with the rest of the part from the chapter. So, our next topic is a hydrometer. Hydro itself means water and meter means any scale to measure. So, here we will measure the relative density of liquids. How we can use the hydrometer? Let us understand by seeing that hydrometer in picture. In a hydrometer, it consists of a beaker in which the liquid whose relative density is to be measured is being kept. Now, this is our hydrometer, a long tube-like structure with a bulb at one end. And here inside the bulb, there are some sorts or balls-like structure of lead are there. That helps to keep this hydrometer upright. Now, we can change or we can keep different types of liquids whose relative density we want to measure. Now, if we want to measure the relative density of any liquid, we will pour it in it and keep the hydrometer inside it. What will happen? Till the hydrometer will be straight upright, the weight of this shot will be balanced to keep the hydrometer upright. Now there is a scale attached with this hydrometer marked over there, or we can take another scale or ruler made up of paper to read the reading. That will give the density of this liquid kept in the beaker, and with density, using density, we can easily find out the relative density that we had already discussed in my first video. Now, lower the density of a substance, further will the hydrometer will sink more. If the density of the liquid is low, then that means the liquid that is kept inside the container or the vessel, if that density is low, then the hydrometer will sink more inside the liquid. And this hydrometer, which is used to measure the purity of milk, is known as the lactometer. Now, we will discuss about the next topic from this chapter is flotation and sinking. How the density of an object and the density of the liquid in which the solid or the substance is to be float or sink. So, in the first case, for a solid to float, if the density of that solid is less than or equals to the density of the liquid, it will float. In other words, we can also say that if the relative density is less than 1, then also the object will float. That means what? As we know, relative density is equals to density of the solid by density of water, and density of water is 1 gram per centimeter cube. So, in denominator if 1 is there and if numerator is less than 1, then only it will be a proper fraction that will be less than 1. That means the value of relative density will be less than 1. Then the solid will float. Some of the examples whose relative density are less are wood, cork, kerosene. These all will float in water. Now, for a solid to sink, what will be the condition for that? If the density of the solid is greater than the density of liquid, then the solid sink down inside the liquid. or we can also say it as if relative density is greater than 1, then the solid will sink down like gold, silver. So thus using this relative density method we can find out the purity of gold and silver as well. Now few applications related to the flotation. The first one is, you must have seen some waxes are found in market or you are using at home that can easily float on water. Why? Because the relative density of that wax is less than that of water. Because of that is a solid, and if that density or the relative density is less, then it can easily float on water. Few more examples are there, few more applications related to flotation and sinking. Next one is relation between seawater and river water. As you know, in seawater many minerals and salts get dissolved in it, because of which the density of the seawater is more than river water. So it's easy to swim in seawater than in river water. Why? Because when a person wants to swim in seawater, as the density of the seawater is more than the density of that body compared to the river water, compared to when he wants to swim in river water. So if density of seawater is more, that means water has more density, it will float more of its body upward or above the water, seawater, than compared to river water. That's why it's easy to swim in seawater than river water. One of the more application of flotation and sinking is Plimsoll line, that you must have heard in standard 7 as well. That Plimsoll line is a mark on the hull of the ship. Why there is a mark? Because when cargoes are being loaded, then due to overload, sometimes you must have heard that ship is going to sink inside the sea. To avoid such conditions, there are some marks being made on the hull of the ship, so as those are the safety lines called Plimsoll line up till where the ships can be loaded. So that will decide, that line will decide that how much the cargo can be loaded. Now moving on to the next topic, that is variation of density with temperature. How with the increase or decrease of temperature the density will vary. As we know, when we increase the temperature, then what will happen? Any substance will expand, or if we decrease the temperature, then any substance, or we cool down, then the volume of that substance will contract. And we had already done that density is equals to mass per unit volume, means density is inversely proportional to volume. So if volume decreases with the variation in temperature, that means density will increase, and if the volume will increase, then density will decrease. Now let us discuss a little bit in detail in all the three states of matter, that how that will decide its density and how there will be change in the densities in all three states of matter. Let us discuss about solids first. In solid, we know that the intramolecular space is very less and the molecules are very close to each other. They are tightly packed. So when a solid is heated, there is no such significant change in the molecules of the solid. They will not move here and there. That means there is negligible expansion, means there is negligible change in the volume. If there is no change in the volume, that means there is no significant change in the density. So with the increase or decrease in temperature, there is no significant change in the density or volume in case of solids. Now in case of liquids and gases, as we know, the molecules are very far apart from each other. The intermolecular force of attraction is very less compared to solid in case of liquid and gases. So when solids are heated, there is no significant change, but when a liquid or gases are being heated, then there is a large change in volume is being observed. Why? Because as the molecules are far apart, they can easily move inside the containers, the gases as well as the liquids. So as they will start moving here and there, as we know we had already done regarding the transfer of heat in the molecules of solids and in the molecules of liquids and gases as well by the process of conduction and convection. So convection takes place in liquids and gases. That means when the molecules of gases and liquids are being heated, they start moving upwards, and as they move upwards, then what will happen? The cool or the molecules having less temperature or cool molecules will come down. Thus, then they will gain the energy and moves upwards. Thus, there is a difference in the density of the layers of liquid and gases. Thus, there is a possibility of expansion in volume and so as in density. So, if volume will be more on heating, density will be less. If volume will be less on cooling, as they will contract, then the density will increase. Density will be more. Thus, the difference in the densities of different layers of liquid. As I told, when we heat a liquid or gases, means fluids, the molecules which get the heat becomes less dense, lighter, rises upwards, and the molecules that is present on the surface having more densities comes down. So there is a difference being created, due to which many natural phenomena occurs, and we had discussed during our last video in first chapter while dealing with the first chapter, that will create the convection current and brings rain or land bridge, sea bridge occurs in nature.